I'd like to open the panel. Thanks for all the panelists who agreed on sharing their knowledge and experience today in the context of the ISM conference. So, that session will be about security, protection, and things to provide attacks from external, also keep resilience in industrial environments, more or less. And I have found some speakers from industry, some speaker more or less at the link between industry and academia, and 2 speakers from the academia itself, which have different focus on security, information security, energy informatics security, security on a very theoretical view. So I guess we get a kind of a hopefully round picture, more or less. Yeah? So the idea of the panel structure would be that I first introduce all the panelists shortly, so that you have an idea on the background of each. And then we have all the talks intermediate. So we had agreed on that we have all the information given in short talks of 10 minutes for each of the panelists. And afterwards we have a collection of questions. We prefer this compared to individual questions after the talk, because we have maybe more flow. So if you have really an urgent question, maybe you ask immediately, but if you have a general question, or if you can wait until the end, then we have a long session where we can have all the discussions after all the introduction of the speakers. Okay, then I'd like to introduce you the speakers a bit. So we have from OFFIS in Germany, Shadi Attarha. I hope I pronounced it correctly. And she's a scientific researcher who started working for OFFIS in 2018. And her current focus on the research is the usage of virtualization in cyber-physical energy systems to improve its resiliency and flexibility, and as well as to model threats in this environment. In addition, she works on communication networks to improve network quality of service through SDN. I guess all the contacts we can also share at the end. And from OFFIS, her colleague Björn Siemers is also in the meeting. So maybe if you have questions to him, he should assist, I guess, his colleague. Then from the University of Klagenfurt, we have Stefan Rass. So we've been colleagues. Yeah? Hello.
Hello.
Yeah. We have been colleagues for a while when I did my PhD in Klagenfurt, and he's meanwhile associate professor at the University in Klagenfurt, and he's specialized in applied security and also doing research and game and decision theory, which is also one of my fields of interest actually. And further research interests include the complexity theory, simulation, statistics, quantum cryptography. He chaired and co-chaired scientific conferences related to security, such as, for example, also the Central European Conference on Cryptography, the Conference on Decision and Game Theory for Security, and the ICRA workshop on security and robotics. Currently, he is an associate professor, as mentioned, teaching courses on algorithms, data structures, theoretical computer science, complexity theory, security, and cryptography. So Stefan will be mainly the one who has the general overview without a very specific field compared to the others. It's really focusing on the security itself, so how I would take it. Then from the KTH Royal Institute of Technology, we have Mathias Ekstedt, and he's a professor in industrial information and control systems. His research interests include information and cybersecurity based on software and systems architecture, modeling and analysis. In particular, the research is applied in the power industry, so we have a good match both to OFFIS and also Simon Kranzer, which we will introduce soon, and to information systems related to physical process monitoring and control, such as SCADA and industrial control systems. Mathias is also the co-founder and chairman of the board of ORCT, a startup company developing products for automated and model-based attack simulation. Finally, Simon Kranzer is from the University of Applied Sciences in Austria. So this is what I'm mainly also introduced as kind of a a link between the academia and the industry. He's a senior researcher and senior lecturer at the University of Salzburg of Applied Sciences there, and he sees himself explicitly as a link to industry, bridging knowledge from companies and the university and its scientific partners. So Simon holds a degree from ITS in telecommunications engineering, as well as a master's degree from the University of Salzburg. And his research focus is the acquisition, preparation, and transformation of industrial datasets and OT security. Simon is a member of the Smart Factory Lab in Salzburg and leads several projects actively contributes to the Center of Secure Energy Informatics, as well as the Center for Digitalization in Salzburg. So you see, we have kind of a focus on energy, but like all, the link is the security and the necessity to keep resilience in that system, to keep it reliable, to prevent attacks from the system, and to make the system overall work. And I'm looking forward to really interesting talks and hope that we have an intense discussion afterwards. Before we start, finally, maybe as a last, my short introduction, I'm Thomas Schlechter, and I'm from the University of Upper Austria. And I'm professor for automotive mechatronics, but I was also deputy security manager at Bosch for a certain time. Therefore, also my deep interest in security and topics in this area, because I think no system today can be and survive without any security features. And with this, I'd like to hand over to my fellow panelists. So is there any volunteer to start? If not, so I guess maybe the best thing.
Thomas, I was just muted. If it's okay, I start.
Yes.
For me, it does not matter.
Okay.
Difference. Okay, so
the stage is yours.
Then try to share my slides.
Perfect. It's there.
You should. Yeah. Perfect. So when I was asked to contribute to that panel, I first thought, okay, this should be some traditional academic talk, and then when we came up with the idea to do it that way, that everyone contributes his or her 10 minutes, and then we all together talk about it, I thought what I did the last couple of years, and to link between the industry and academia, I came up with some other form of talk. So I tried to bring up some ideas and theses. What are the main challenges for security for actual companies at the moment? In the last 10 or 15 years, all people in industry, or most people in industry, and lots of people in academia tried to interconnect all the machinery and all the devices. That's what they call Industry 4.0. When you look at most of the definitions or marketing slides for Industry 4.0 or IoT or IIoT, it always deals with connecting something or collecting data, bringing out new information, but what you will not find that many or that often is concerns about security, especially in the beginning of the whole fourth revolution. So if you look at the definition or the marketing definition of the platform Industry 4.0, Industry 4.0 is intelligent networking of information and and with the help of information and communication technology. So most effort in the last 15 years has been done by interconnecting and networking and bringing things together, making tools smart, making production smart, making something clever was the main focus. Same with the Internet of Things. The Internet of Things is the idea to network physical objects, to make them communicate with each other, and to communicate with some external environment, namely the cloud or other information sources, and vice versa, provide data to that cloud or community. Again, if you look at IoT in the beginning, if you look at the IoT marketing slides, no concerns about security, no security involved. The IIoT itself is the interconnection between those two. On the one hand, Industry 4.0, on the other hand, the Internet of Things. And again, we want to interconnect machinery. We want to bring everything together. This leads now to some figures or some numbers. So we have worked at least 10 years on networking cyber physical systems. The collection of data fires numerous new business models. Interconnecting devices enables and improves thousands of services. Just in 2019, still a lot of German and Austrian companies rated IoT as really very important, and the sales numbers are, even if those are not maybe not the perfect numbers, but they are really doubling or increasing stable in the last years. And that's in my opinion, the today's situation. Today's situation is we worked hard to interconnect, to enable communication, to network, and this leads to a new situation because security was mainly thought by using in the industry the ISA99 model called Purdue model, which was the main idea of providing security for the production sites and for all the interconnected devices. Maybe some of us can talk later about that. If this model still is suitable, there's a lot of arguing going on about that model. But in every slide, in every conference, in a lot of books, I always read these three words: security by design. And my thesis for today is that we already interconnected everything. So we are facing a brownfield situation mostly, even in Industry 4.0 ready or enabled production. Most current security solutions rely on IT security strategies, but security by design is not part of Industry 4.0 and is not part of today's solutions for IIoT. And traditional IT security strategies often fail in real world production. So I want to fire up the conversation by stating that standard IT security is not suitable for OT environments. The standard answer to security in industry does not fit this highly networked world. the requirements of modern production, namely being fast, being cheap, always conflicts with, or often conflicts with security concepts. The current production environments are not secure by design. The current IIoT is not secure by design. So security has to be thought and implemented at the production level in the future. But this is, in my opinion, a brownfield challenge. So those are my contact details if someone is interested. So thanks a lot for the time, and I'm looking forward for the other talks and for the upcoming conversations. Thank you.
Yeah, Simon, thank you from my side for your interesting insights in your topics which you dealt with in the recent years. There's really some things I also observed like that, and the developments and the problems. So maybe it is like a good follow-up to deep dive a bit more in the industrial environment, which is also research-based, but still very much linked to the industry. And I would invite Shadi from OFFIS to present, if this is okay for you.
Yeah, it's totally fine. I can share my screen now.
Perfect. So stage is yours.
I cannot share. And now my screen is shared, true?
Yes, but we see the edit style from PowerPoint, so we see the slide, but not the yes. Now it's the whole slide. Now it's present. Perfect.
Perfect. Sorry. Okay. Hello again. Today I prepared a presentation regarding the usage of virtualization in cyber physical energy system, its promising advantages and challenges. Also, I want to explain more about the security concern in this area. And after that, providing the solution and recommendation to provide a basic security mechanism in this area. At first, I want to talk about our motivation to using a virtualization in power system. Nowadays, by growth of the number of participating actors, for example, active consumers, as well as increasing disruptive events, the challenge of reliable operation in cyber physical energy system is continuously increasing. So in order to improve the reliability, improve the ability to observe and control the energy system, ICT has been integrated in the power system. Therefore, reliable operation of the modern power system are dependent to automation system and ICT somehow. But the operational flexibility of the automation system is somehow currently restricted by integrated hardware software setups and vendor-locked solution. And this makes difficulties for reconfiguring the control strategies during the runtime. Virtualization here can be considered as a potential solution for solve our problem, because virtualization can provide the ability to reconfigure the system and bring the flexibility by decoupling the software from underlying hardware. So we have a new idea and called it grid function virtualization. Grid function virtualization as a potential approach to improve the operational flexibility of the power system. In this regard, the grid services such as a voltage control and state estimation, which are traditionally bound to hardware, now can be realized in a virtual machine or container, and can be deployed independently from the hardware through virtualization. This enables the ability to reconfigure grid services as well as relocate them based on a real-time power system requirements. As we can see here in the picture, the grid services deployed in a multiple virtual grid functions, and the chain of these virtual grid functions cooperate with each other to bring us grid services. So we can say, all in all, we can say that the virtualization brings us the operational flexibility by reconfiguring the grid services during the runtime, dynamic resource allocation between the different applications also in the runtime, and improve the system restoration mechanism when something disruptions happen. But that are promising advantages that virtualization brings to smart grid. However, using the virtualization poses a new security and privacy challenges. The implementation of the grid services as a chain of software-based virtual grid functions provide the ability to monitor and configure them by an external agent remotely. Here we call it orchestrator. That makes the power system can be potentially completely disrupted and compromised. In other words, we can say the attack surface will be expanded from the hardware vulnerabilities to vulnerabilities of a virtual entity. We call it virtual grid functions, orchestrator, and administrative error. Therefore, the use of virtualization for the deployment of the grid services needs a domain-specific threat assessment. For depicting the virtualization concerns that can be appeared in this system, here we assume that we have two devices and each of them has a multiple container. They are connected to each other via internet and managed by the orchestrator that is located in another device. Also, there is a repository for storing the images, and each device can access to this for pulling and pushing the image over internet. At the first model, the potential threats on each device, we can divide them into 4 different categories. Application attacks the container. Application attacks the container. Container attacks other container in one device. Containers attack the host, and host attack the container. Also, there is one problem. There's several potential threats between the devices here, as we can see, and between the repository and the orchestrator. So, at the first, I want to focus on images because, as we know, the containers are made from the images. Image vulnerability can cause several attacks that I mentioned in this table: unauthorized access, network-based intrusion, and untrusted image. This makes a system vulnerable and can cause problems between the containers, applications, and the worst case can hacker hack the whole system. So there are some general high-level solution in a container environment, and recommendation can help a system administrator to provide the basic security protection, as a running application and the least privilege using the containers runtime API and using the up-to-date images for running our container and trusted images. So we can say if the image is not configured well, can cause a serious problem in the whole system. Also, we use the repository for storing our images and to deploy our container. So it's important the connection between the devices and the orchestrator to the repository is completely secure. So the unauthorized access or listening to this connection can be caused a very different disruption in the whole system. And the it's important that the up-to-date version of each images is stored in the repository. Also, we can use a controlling the access to the repository should be very strong. Another important problem that causes serious consequences is that the control commands from the orchestrator or a command line are stored in a clear text. So all this controlling information as well as authentication information can be hacked. A basic solution and recommendation in this area is to encrypt all this sensitive information over the internet. In a containerization method, because the host and the containers share the operating system, it's important to limit the exposed port in a host. So by restricting the access to the host can protect the containers and application from the DOS attacks and flooding problem that can be occurred. At the end, I want to explain about the poorly separated inter-container traffic that can be happen because of a different type of the application we are running here and a different sensitivity level they have. So it's important to create an overlay network to separate the different type of the traffic and can make the secure environment for a more sensitive application here. And can provide a basic secure protection in this environment. I finished my slide. I can stop sharing my screen.
Okay, thank you, Shadi, for that insight on like real problems and your personal focus in like dealing with these issues in the overall grid. I guess a good extension at that point will be given from Mathias. So I think basically it's best, Mathias, you continue and round up the energy sector image, and then we get a soft like overall overview from Stefan at the end. Okay?
All right. Thank you. I will share my screen. Do you see the screen now?
Yes, but we see the MS Teams.
Okay, there's some delay perhaps.
Now it is there.
All right, I think, yeah. Well, this is one of the things you learn when being in Teams meeting, that there is a I have had problems with delays showing my slides. Anyways, I hope I can do that. So thank you for inviting me to the panel. I was planning on spending some time on well, a few slides on what I see as a big problem in this area, and then a few slides on what the potential solution could be to that problem, and relating to the research that we do at KTH. And this is about threat modeling and attack simulations. So the problem then first, as far as or when I think of the problem, then we have large interconnected systems. So this is in line with Simon was saying, and also the brownfield thing, that well, there is a mix of old and new. The latest IoT technology is mixed with old control systems, and all of this together should work as well in a, say, good way. So here's a picture trying to, say, represent such a system. The picture is taken from a power industry context, but also for, say, the industry 4.0, it will be something similar. Now the question is, how, if we look at such description here of the IT infrastructure, how secure is it, or how resilient to attack is this infrastructure That's essentially the problem. Now that picture was very simplified, and here is perhaps a picture that represents the real complexity of systems. Many systems highly interconnected to each other, and just understanding how interconnected all of these things are is just a challenge in its own right. So that is perhaps the picture we should have in the back of our head, but it's kind of complicated and irritating to think of it all the time. Also, the situation gets worse. Now, if we look, sometimes we see pictures like this, the smart industry, and then of course for every part of this domain, it is we have this complexity in every detail. So there is the problem that I'm sort of putting forward is the complexity, and that's something we have to deal with. Now, all of these systems, we also know that they will be vulnerable. So it's not a question of can we say design the system so we know that it's completely secure. No, we cannot. There will always be vulnerabilities around. So the question is rather, how do we manage it? And the trick is that, well, then you can also say, well, we know what to do. We know there's a long list of things that is good to do for security. We must make sure to patch our equipment. We must make sure to introduce intrusion detection systems. We should use proper access control and proper authentication and so on. So there's not we have a lot of say information or a lot of knowledge on how to secure systems. So that per se is not a problem, or is not a challenge. The challenge is rather that, well, we cannot have all of it all the time for various reasons. Maybe our budget and time restriction doesn't allow us to introduce everything, but also in our environments where we have control systems, we might simply not, for operational reasons, perhaps we don't want to patch systems as often as we perhaps do in a more office environment. So the problem there becomes more of, okay, so what kind of, if we choose only a few of those things, which ones are better? And if we can, is there a certain combination of say, solutions that we should choose? And choosing this is kind of a challenge, and it's an increasing challenge with increasing complexity where more systems are interconnected. Okay, so that's how essentially I see the problem domain. Now going to the say potential solution domain, we engage in threat modeling and attack simulations, and then there is a famous quote that I like that is good for illustrating what we do, and it's from Microsoft initially, and a man called John Lambert. He said, defenders think in lists, attackers think in graphs. As long as this is true, attackers win. So what he is saying here is that defenders, they are trying to penetrate environments and doing one step at a time. And there's also this hint of the asymmetric situation we're faced with, that the attacker only needs to find one hole while the defender needs to defend all of these potential holes. Okay, so coming back to the problem then of how to defend a larger architecture with a lot of components, then one problem is initially also just figuring out what we mean with security in such an environment. And the way that we tend to think of it in our research, and also other people do, is to think of it in terms of how difficult is it for an attacker to reach from one place in the architecture to another place in the architecture. So there is an entry point, and there is a certain way that the attacker will say go about to get to the target, and how long time it will take. that's sort of a definition of security here. So given some defense mechanisms and some vulnerabilities, the attacker will somehow penetrate the whole architecture and get to the target in some way. And it will take some time, and that will be, say, a way of thinking about resilience or vulnerability or security. And with more defense mechanisms and with other, say, vulnerabilities, the attacker would need to go about in another way, which will take them longer or shorter time, essentially. Okay, so how do we do this in say, in a more structured or like a formal way of thinking about it? What we are using is something called attack and defense graphs, and here's a simple example of that. It is the thinking like an attacker. So in order to, say, break into a house, there are various ways you can go about. You can break into a window, or you can break into a door. And in order to break into a door, first of all, you need to, say, get access to the door, and then there are various means to break in through the door. You can use the key, or you can pick the lock, or perhaps use a big sledgehammer. You can also try to protect your environment, saying that you have a good lock or a good steel door rather than a tree door, and you could have a fence around your house. And that will then make it more difficult or easier for the attacker to succeed with what they're doing. So this is the way we then try to model how attackers can go about penetrating environments. Now, an interesting thing here is that we want to observe that these attack steps, they relate to the, say, components of the system in this case. So the house and the door and the various the attack steps and the defense mechanisms relate to those concepts. And it is only when the door is located on a specific house that breaking in through that particular door helps breaking into the house. And it's only when there is a fence, certain it makes it more difficult to get access to the door in the first place. So depending on how the system looks like, it's possible to then generate various attack vectors here and then simulate attacks beforehand. All right, so if we're talking about IT, we're not talking about doors and fences, we talk about other things. So instead we talk about hosts and services and data flows and users, and attacks are, we can do man in the middle, and we can do SQL injections, and we can do different various things, and we can defend ourselves with patching and turning on our ASLR in our operating systems and so on. So but the idea is the same. Just to give you a very short idea of what this might look like when we apply it to the IT domain. This is some results from previous research originating from an EU project called SegGrid, where we did this for load balancing of distributed renewable energy. So in that case, we had a system environment looking something like this. I'm not sure if it's how much delay I have in my slides here, but there's a lot of components. There's a lot of IT infrastructure interconnected in order to be able to do this load balancing. And for all of these environments, they are, say, have some details related to them. So here, for instance, this is a SCADA environment. This is similar to what my illustrative could place an attacker on the internet, and then in this particular case, we wonder, well, how difficult would it be for the attacker on the internet to get to the central control SCADA system? So the attacker is the red bubble here, and the target is the blue bubble here. Then there will be a number of attack steps, and these are quite many. But to give you some sort of overview, what happened in this particular case and what kind of results you can get, it will be something like this, that in this case, there was first the attacker compromised a web browser by doing spear phishing and some cross-site scripting. And then they harvested some credentials to compromise another computer, which in turn new credentials were harvested so they could log on to the SCADA HMI and then do a privilege escalation attack to actually get hold of the central SCADA database. So, and then as a final note, what we can do with this and how it could help us improve is that as we are also thinking about and modeling, say, defenses that we could put in and make the attacks more difficult to succeed with, we can start looking about where could we have put more defenses in, and then that would then, say, improve hopefully or make it more difficult for the attacker to succeed with their attacks. So this is also, say, a design support thing, and this is of course what we want to get in the end. So to me, the security problem is very much the managing of the complexity that comes with the increased interconnectedness of our environments, and this figure here is an illustration of that. So this is such an attack graph where I think the black node in the middle is the attacker, and the purple one just next to it, also in the middle, is the target. And for a quite small environment or a small model we have modeled, these are all the potential attack vectors to get for the attacker to get to its target. And as you see, it becomes an enormous amount of attack vectors. So just keeping track of all of this, understanding what all the attack vectors are, it's virtually whoops. All right, I guess that's ended my talk. But so what I wanted to say, just as a last thing, this is security is to a large extent a complexity problem, something that we need to manage one way or the other. All right.
Okay, thanks a lot on this insight. I think like the complexity issue is something everyone like observes, and dealing with that complexity, it's already has been addressed a bit by Professor Zeutl this morning in a different context. So I think that's really a good point, bringing some additional insight into that topic. And I guess this will be a good source for discussion later on as well. Maybe to conclude now the presentation series, I think Stefan will get some additional new insight in the overall security topic, and open the stage afterwards for the discussion. Stefan, you ready?
Thank you very much. Yes, I hope so. I'm just sharing my screen. Give me a sec. So, see, is there a delay, perhaps? No, sorry. I'm just trying to share my screen without showing you any edit or other. Okay.
Yeah, the data to cross the mountain to dream, right?
Yes. So can you see my screen?
Now it's there. Yes, perfect.
Perfect. Yeah, welcome also from my side. I'm very happy to be in this panel. I hope you're all safety and healthy in these days of Corona. So yes, when you were inviting me, Thomas, I was quite flattered and thought if I could share some of my own insights and things, thoughts on what could be done in future of Industry 4.0, because what we see in today, and I think what we're going to continue to see, is that the production environments are being highly networked with lots of outreach to externalities and also internally. So we have complex supply chains there. We have lots of internal details. There is office networks. There is supervisory control and data acquisition. There is the production network as such, up to robotics networks as a particular instance of. So there is lots of connectivity, and in turn there's lots of actors involved there. And the situation is, in my perception, one with very, very many local views, which is separation of duties induced. Like we don't have one person being responsible for everything. We have many persons responsible for their very much delineated parts of a network, and everyone has its local view, but it's hard to get an overview, a global view in a way. And the division of physical and cyber is one problem there, because we have people working on physical aspects of a system. We have people working on the cyber aspects of the system, but those two aren't naturally compatible to each other. They can't even really very intensively talk to each other. If you come from a cyber world and you try to explain someone in the who's spent the last 40 years with engineering of electrical systems and stuff, he might have very deep knowledge there, but not as much deep knowledge on cyber attacks, and simply has a difficulty to see where's the problem. We do have the power, the lights are on, I don't see the issue. And things like that. So those are let's say fragments of discussions that I picked up when we were talking to people from industry, really in projects. But the contemporary situation is really such that what we have today is what we call an advanced persistent threat. So the attacks aren't something spontaneous. They are being planned on a very long term. They're very target oriented. So it's not that I would fall victim to like a collateral damage, but if we're today having this kind of attack, cyber attacks, they're very targeted. They go unnoticed and very slow and stealthy over weeks and months. They're very highly customized. So it's not that I'm being hit by some, let's say, general purpose malware. It's really I'm being hit by some malware that has been handcrafted just for me. And the point of all this, or the goal of all this, is to, once the symptoms become visible, so that I really noticed, okay, I have been hacked, it's already too late to do something about it. And the real problem is the recognition time. It's like with a normal disease, like with cancer, the earlier you get to knowledge about that you have a problem, the better your chances are to cure it. Detection times in Europe are roughly, I think, 200 days between the initial infection and the recognition of the fact that you have been hacked. America is a bit ahead of us. I think they have an 80 days delay between the initial infection and the time when they recognize it. And I like to compare this really with the diseases, and I'm perfectly aware that this could be problematic in terms of corona, but the analogy, I think, is still there. An advanced persistent threat or cyber attacks today really go like a disease. There is an infection event, there is an incubation period, and then there is an outbreak. And the incubation is particularly what Mathias has been describing before. It's more or less a matter of scanning and penetrating the system over an attack graph to learn what you can do there and to leave traces and to remove your traces, but to leave backdoors and stuff. And that is the phase. The spreading phase is really what takes weeks or months. So we know about APTs that have been running for 2 years before actually some damage was being created. So just to give you a temporal idea of what we're talking about here. And that's has been growing into a whole business on its own. It's called Cybercrime as a Service. And it's really a kind of an allusion to cloud computing. So everything as a service, why not have cybercrime? Well, if you're interested in, let's say, ruining somebody, you don't have to become a cyber terrorist on your own. You can approach your vendor for the malware. You don't have to write it yourself. You don't even have to place it on the victim's computer, because that's what your friendly spammer does for you. You don't have to run your own infrastructure, because running a virus takes a computer that's being switched on 24/7. Who's going to pay for the energy? Well, you can rent your infrastructure as much as you can do with any other cloud service, only for illegal purposes. And finally, once you have collected your money, you don't need to be an expert on banking over the Cayman Islands. That's what the money mules are for. They perfectly manage on hiding the flow of the cash. So it has become a cybercriminal ecosystem. It has become a service. The most popular currency in there is Bitcoin, actually, because of its anonymity. But as you can see, you can buy pretty much everything that you need. You have a full supply chain to hack people and to run an advanced persistent threat. You don't have to be a specialist on your own. You have bonus programs with customer benefits and stuff, everything that we need for that we know from a normal market, only it's illegal. So what we need to counter that, I think, and that's the person that I want to share with you, is kind of a holistic security management. And I really apologize for the term holistic. I hate that term. I think it's one of the worst terms ever. But in a way, it fits here, because we need to keep the whole picture in mind. And security is in a way special, because there is, first of all, there is a dilemma. Security doesn't create pleasure. It prevents losses. And because it doesn't create pleasure, people don't see the point in why should we add more security? The system is running. We don't get any additional pleasure from doing security besides having more work, and that's the opposite of pleasure. And there are even psychological phenomena which are called the prevention paradox. You see some risk coming up and you do something about it because you feel, well, we should protect ourselves against, then nothing happens, perhaps thanks to your prevention. And after, in the end of the day, people say, well, why did we go through all that mess? Nothing serious happened anyway. We didn't need the protection in the first place. So that's what we call the prevention paradox. It's a documented phenomenon that particularly applies to security. And my favorite is overtrust in technical protections. So I've seen many people switching on the technical protections and at the same time switching off their brains, just fully relying on the technical protection. I do have a virus scanner, I do have a firewall, so I don't need to care for security anymore. That's simply not true. And that happens in many dimensions. Even if you go for an additional security precaution, you might not be, people might not just fully be aware what the technology can do and what it can't do. And I was putting that again, referring to the complexity that was mentioned before. There is technology out there that people simply overrate. And again, no offense, my personal favorite is the blockchain. So people think of the blockchain as the solution to pretty much every problem in the world. Technically, it's not. And I've seen many people just asking, why don't we use blockchain without actually precisely knowing what it can do, and more importantly, what it cannot do. And the other technology that you see very highly rated these days is artificial intelligence. Can that help? Again, I've been asked very often, can't AI do something for us? And I said, yes. It can, when it is used to automate repetitive, cognitive, and hence boring processes for the brain. No, when you take it as a substitute for human intelligence. And that's unfortunately a misperception that I've seen very often out there. People seeking to get help for something that they feel, why don't we approach science and people from the universities to help us there? Can't you do AI for us to handle a certain task? Well, no, we can't, because you have to do that. The AI is only a tool for this, but still it's a very nice primitive and technology to use in security in many, many ways, as soon as you do it right. So what we propose here is model-based security, which of course is to reduce complexity and to help systematize the understanding. So we think that best to go where there is to, let's say, layerize your system in a way to say, think there is an IT domain, there is an operational technology, there is a physical layer, and go for a model of each of them separately, because you have people who know how IT behaves, you have other people knowing how the operational technology behaves, and you have further people knowing how the physical layer behaves. So why don't let each of them build their own models to reduce the complexity and then create, let's say, in a way, digital twins to have a copy of your system that virtually behaves like the real system and on which you can study the effects of countermeasures and attacks. So the proposal or the approach that we pursue in research today is to use artificial intelligence to give us a digital twin of a system that we can study without fiddling with the real system. And that digital twin can be created from expert knowledge. If you just say, well, if something happens, then with some probability something else will happen. If you can manage to a description on that level, we have already very good simulation models to play attack and defense games. So artificial intelligence as one of the, let's say, en vogue technologies today, it can automate many processes where human experts are required. Let's say risk assessment and stuff. It can help to build community knowledge in a way secure and reliable way, which is one of the bright sides of it. And it helps to describe complex dynamics for simulations for security, because you can actually describe your system behavior by examples. But it comes with dangers. And that's one point that I want to make here, that I also make in projects many times. You can't have artificial intelligence replace human intelligence. There is no artificial intelligence that is even remotely comparable to human intelligence. Second, it's far from being robust. There are attacks on the AI system. If you have a recommender system that's based on AI, you have very well documented and very well-working attacks to trick the AI into giving you completely incorrect recommendations. And there is the data leakage issue there that's also hasn't seen too much research. We're working on that particular issue at the moment as well. Do I have loss of intellectual property if I'm giving away artificial intelligence mechanisms, let's say for a security assessment? So that's a more deep research question that we're working on, but still AI is a good thing to use as long as you use it carefully and as long as you don't create additional danger from AI. So personally, my point here is what we need is, I think, usable security. You have to simplify things for people to help them comprehend what you need and why security is important. And what we also need is security economics. Security is not the absence of danger. Security in the game theoretic perspective is a position where attacking you is more expensive than leaving you alone. And that's the point that we need to reach. If you allow me for an analogy here, if two people are running away, if I'm running away from a lion, I don't need to be faster than the lion. I just need to be faster than the guy next to me. And that might be an unethical view, but still, it's the point of security. You just need to avoid being the weakest link. And that's what we're looking for when we use game theory for security. So we really do play attack defense games on attack graphs. We have very detailed and comprehensive results on this, which is why I was so happy to see the attack graphs in the previous talk coming up, because that's exactly the playground that we're working on when we use game theoretic security. Second aim of research would be if you should consider security as an investment and return on investment matter. You pay something, you get something back, but that revenue is not really adding to your money, it's preventing loss of money. And there is choice theory and game theory and economic theory to help you with that. And the third ale, which I think is most interesting, is the concept of self-enforcing security. So if I can make following the protocol more paying than not following the protocol, I incentivize people to care for security, and that would actually add to security in first place from a very intrinsic point. And I guess that's kind of concludes my point here. Again, thanking you for inviting me, and handing back to you, Thomas. Thanks.
Okay, Stefan, thanks again also from my side. I'm happy to have you also with us in this panel. And I think we got really some interesting insight, and I see a lot of links between the individual talks. So before we start maybe the overall like discussion, I'd like to summarize a bit my view I got. So one thing is that basically every one of us as like security experts, you see the need for some kind of security by design, right? So the security by design should be there. So security should not be anything which is like introduced afterwards. But this is contradicting a bit, first of all, to the kind of limited budget. Like we saw with Mathias said, maybe we have a limited budget. Like Stefan said, for example, you have no additional pleasure, which is a big problem for implementing security, but you have to prevent losses more or less. And this is not like I get anything extra when I pay something, which is not like very common in the heads of some managers. Yeah. So you need to like invest in the security, and you need to invest even more if complexity increases. But the complexity by introducing a lot of additional links and all the communication, which is like increasing, like Alois Zeutel today also, like the mechatronics view, forgotten always is like also the communication link. So this is not like a overlap of 3 areas, but it's an overlap of 4 areas, and it's getting more and more in the people's mind. So communication increases, complexity explodes, and then on the other hand, you should design security and do this on the lowest cost possible. It's kind of contradicting, yeah. Also, artificial intelligence, as Stefan said, it's basically not like the holy grail of everything, but maybe artificial intelligence can help also to handle that security. I don't know. Maybe if the trust in artificial intelligence is bigger, you might, with this outcome, also convince maybe some managers to get your budget and also to make more trust in the security, which is kind of ambitious. Yeah. And what Shadi said, quite interesting, is like you like to prevent, to communicate or have a direct link between the individual containers they are using. But what you are doing actually is like you introduce additional complexity. Yeah. So you increase complexity because you cannot handle the complexity. And this is, I think, kind of a bit awkward as well. And I think this is maybe a good stage for discussion overall. If you take all those findings and those facts, maybe where is like the opinion of everyone, where security is actually going. So where might be the balance? Is the complexity running away and we cannot catch up with the security? Or do we have like to focus in a different way on all the security issues? So what is the basic opinion of the whole crowd and of the panelists? And of course, if you have additional questions or comments or remarks, then please feel free to like share it with us. So I open the stage and thank again like all the panelists and hope we have a fruitful discussion now. If you want to say something, best I guess you raise your hand and then I will call you. Stefan, please.
Okay, thanks. First of all, let me also thanks to the previous speakers. I very much enjoyed the talks and they had very, very good points. I think what you say there, Thomas, is perfectly right. It's kind of let's say a trade-off that you have between investment and what you get back from it. This is really scientifically one of the reasons why we're looking so much into game theory, because it's optimization of opposing and conflicting goals, where you seek an optimal trade-off as an equilibrium. So that's just behind the technical reasons why we're looking into that. I think methods like were proposed with with containerization, virtualization, also the use of attack graphs, those are inevitable, and I think they should gain much more interest and practical use, because you reduce complexity, and that's the only way of tackling anything. So yes, I think the directions that have been presented here are very, very nice and interesting and good to go. Just let's hope we're not remaining the only ones to pick them up.
Thank you. Mathias, please.
Right. So yeah, I agree. I also think that complexity it's say inevitable future. I think that there is too much. Say there's so many benefits from integrating things and from adding more features and functionality. So I think that we will just have to live with that, and then it becomes a problem of managing it. But I also think that it's possible. I mean, we do have a lot of, say, new technologies and research that is supporting us. AI, I mean, is the hope for a lot of this that hopefully can help us doing this. But even without it, I mean, it is in many other engineering disciplines than the IT. People have made very complicated models over things and analyzed very complicated things with, say, more traditional approaches. So why should why shouldn't the IT domain also be able to do the same? So our capabilities are better and higher, but the complexity is constantly increasing. That's my view on it.
Okay, thanks a lot. Any questions from the crowd? Simon, I see your hands, great.
Thanks a lot. So it's really interesting. I really like the term usable security or make it usable. I think for the production and for the small and medium companies, this is really important to make it usable. They did the same in safety. Still, safety, maybe safety is more feelable for the companies, but it has to be usable anyway. So usable security, I think, is a great term for bringing security to especially small and medium companies. What we also see in the last years is that there is somehow an information barrier between the different worlds. So if you have your IDS, it collects data and it analyzes and it detects anomalies and whatever. But most of the time it's not connected to the SCADA world or to the network world in OT. So no information about the character of the protocols, the types of devices is sent to the both other worlds. So I think this, and we try a lot in this direction, is also could also help both worlds when this meta information is usable by both sides.
Sure, yeah, completely agree. Thanks for this insight. Any question from the audience? So there's many people in the line. I guess there's some things you're really interested in. Take your chance. If not for the moment, maybe it's going to settle a bit. What I would be interested is also from any of the participants, have you considered, except for Stefan, of course, game theory in the field of security in any way, or are you applying game theory? Is this on your screen somehow? Yeah, Simon, please.
So we now are often thinking about the same thing with the digital twin that one of you said. Sorry, Mathias, no. But game theory, of course, is an interesting idea to use it. So now nowadays we really focus on creating digital twins and try to use it for security considerations and try to use it to train or enhance IDS performance.
Okay. Matthias, yeah?
Yeah, so, we haven't really worked with game theory in an explicit way, but I think it's a good idea, and this is something we have, say, touched upon, but no really concrete results of it. But one thing to say relate to that question is that there is also, say, in my head, a dimension of security analysis that is not so well captured with game theory, and that is that the game theory is good because we try to find, say, what should we do to counter a particular attacker. So of course security comes with, say, it's all, I mean, it all stems from someone trying to do something bad to us. So there always has this active element of it. On the other hand, say, for instance, one way that we do most of our analysis now is we try to figure out what are the weakest links in architectures, and that would be, say, where the hole is. The biggest hole is somewhere. Whether or not the attacker actually finds it at the end of the day, that's another question. And then you end up in, say, a philosophical situation that, okay, so we found the biggest hole now in our architecture. Does it make sense to fill that hole and try to counter it one way or the other? Well, I would in one dimension say, well, of course it does, because we have found this is our weakest point. So we should, if we want to increase security or, say, increase resilience, then this is where we should invest our time and money or protection. But you could also say that, well, if it's a big hole and the attacker never finds it, then why would you care? So there is, I think that there are two dimensions to it. You might or you might not want to be very explicit on what we expect the attacker to actually do. And so I don't have a clear, opinion on how to deal with this, but there are these two perspectives on it.
Okay, thank you. Stefan, yeah, please.
Well, that's a very good point that you brought up, Matthias. And technically, even the theory, if you apply game theory, confirms that. So once you figure out an optimal attack strategy for the adversary, you can go fixing that, say, and that doesn't mean there is no alternative optimality here. So in theory-wise, it comes as non-uniqueness of the equilibrium. So we do see that phenomenon in the model. The other point that you brought up here with the multiple dimensions, equally important. And again, if you cast this as an optimization problem, it opens the direction into multi-criteria optimization even. So you can include costs for an exploit versus costs for a discovery, which is the two dimensions that you were mentioning here. Plus you can add any other dimensions that as you were saying, it may come to your mind when you think of it, even when you think a bit deeper. So it is kind of doable in a way, but of course it depends on how well you can do the modeling. And but again, like scientifically, it opens lots of beautiful low-hanging fruits on research, because the traditional game theory doesn't cover very well the particularities that security brings in. That's what personally makes this field so interesting for me, because game theory is a nice theory in economics. It has its deficiencies in security, but this is precisely what we're looking for in science to solve a new problem theoretically. That's what makes it fun, besides that security is fun anyway.
Yeah, and I agree, and also I think that, so for instance, all the analysis that we want to do with the attackers, they are, well, when we do analysis before something happened, then all our assumptions on the attackers are just, say, assumptions on who might possibly attack us. and afterwards, of course, things happen, and then, well, then maybe we want to use it for forensic purpose. But so I think, to me, ideally, I mean, so what we do is a lot of, say, we assume a completely rational attacker in the simulations. But of course, you would like to, say, filter it through various, say, threat intel on, okay, so this particular attack crew, they are good with, I don't know, phishing campaigns. So they should, you know, they are likely to do phishing campaigns, and we should look for attacks over there. Whereas others are good at exploiting Windows environments or control systems or whatever, and maybe a combination of. And then if you, as you also introduced, if we think of it as cybercrime as a service, then we know that we have very skilled people on all of these possible parts of the overall attack vector, and then maybe we're closer to, again, to say optimal attacker persona. But yeah, there are so many interesting ways of cutting and slicing this, where I think game theory is good in general, but there are also, say, challenges in how to apply it, and the way that we think of it, which is as you're saying, there are so many beautiful and interesting things to look at here from a scientific point of view.
Yeah, please.
Thank you first for the very interesting talks. I have a question. How do you generate the attack vectors? Do you create them automatically, or?
Well, if I can take a quick answer, I think Mathias will surely add to it. There are tools to generate them. So you can run what we call topological vulnerability scans, which bring up such lists of vulnerabilities, and there are also tools to connect them into attack graphs. I don't know about any commercial status there, but scientifically there are many tools have been developed, so you can automate that process to a certain extent, yes. And auto-generate it.
Okay. And one point, what I was missing are people. So I think, Stefan, you showed a picture with the IT, and on top there are, what I was missing, the layer with the people. So yesterday I learned only amateurs hack machines, professionals hack people.
Yes.
And I think this is what is always forgotten.
Yeah. That's what I was. I made that point implicitly, or tried to make it when I was in my concluding statement, that there should be, let's say, an economic, more or less, revenue system for people to invest in security. So if I'm, or to take away risk from people, or to identify that a certain person is really, in a way, the most vulnerable spot in the system, because I've been talking to people from the Austrian intelligence agencies, and they actually told me if the other agency figures out that there is only one administrator in charge of that server, then they're going to take care of that person, whatever that means. And yes, that's kind of a vulnerability that has to be included, and yes, it needs to be in there. Again, coming from the purely theoretical side, we have the area of bounded rationality, where you try to describe people's behavior in light of different what they perceive and how they can be manipulated. We personally looked into things like disappointments, where we're trying to model the phenomenon that you actually did something for security, but you still got attacked. So it didn't work out. So you find that, okay, that apparently did not work. I try something else. Although what you did was actually already a best effort, but it incentivizes people to do something else. So we're also working on that psychological dimension there. But your point remains perfectly right. So it's really something to include here, and that's, I think, touches deeply into psychology here as well.
Frank, also thanks a lot for that question, because there was also something I'd would have liked to add for that, because we're talking about the complexity of the systems, and I think like complexity with increased communication links, complexity with more spread devices. This is somehow and some kind of deterministic, well, of course not to the very end, but primarily I think it's a deterministic thing. And I think this could be covered and dealt with artificial intelligence. This is like something we can do. But a huge part of complexity, which is like getting into the system with our change out there, is actually like the human being, because you have interaction with the system. In the past, you have like your electricity line to the house. Now you want to know all the specific data on your smartphone. So the person and the people are actually involved in everything. And when I got to the game theory a bit, at the beginning I was surprised in which areas it is applied. And I had the feeling, compared to, like Stefan said, artificial intelligence is not a replacement of the human mind. I have more the feeling that game theory is more capable to cover this psychological field, because it is about games and all people are kind of gamers. That's our nature. And I have the feeling that with game theory, you could more and more precise model the human behavior, and maybe that's intrinsically also some kind of an idea why it's conquering more fields. Maybe not intentionally, but maybe this could be some add-on for the nature of game theory. That's a bit of my feeling I have. Mathias, you wanted to say and add something. Frank, you're still raising your hands. Is there something open?
Sorry, no, I wanted to put it down.
Okay, then thanks again for the question. And Mathias, you can go for it.
Right. So yeah, I completely agree. I think that humans is and organizations are a big part of the security equation, and it's I think it depends on your own how you decide on how to delimit the question. So as was mentioned earlier, there is it was the holistic thing. Of course, it is a holistic problem, regardless of what holistic really means there in the end. So, I think that you could possibly also argue that all of this IT stuff, it's not so important at all. It's just a small fraction of the whole problem. And the major problem lies with, say, on the human side. So yeah, I agree. I think what is interesting also is that I think that a lot of the say methods and approaches we're trying to apply, I think it is equally well equipped to work on both the technical and the human side of things. So I think this is we're in a good position there. Then of course it's difficult because the underlying say theories and the actual say behavior of the things is completely different on the technical and the human side. You need to be a psychology expert to understand how people think, and you need to be a computer science to figure out how the computers think. And so there's it's a multi dimensional say theoretical or domain problem also.
Yeah, thank you. Any more insights, questions? Shadi, how do you see yourself in that environment?
Actually, I am somehow new in the security domain, but it's really interesting for me to can find a solution for somehow we can say for modeling the threats and the security concern in this area, because I found it very complexity in this topic, and the different type of the attack vector can be happen. So I found this presentation today so much interesting for me, especially the presentation from the Mathias. It's really interesting, and I want to know more about this. Yeah.
Yeah, but happy to hear that, like the networking paneling, it's fruitful. That's pretty great.
Yeah.
So I think, yeah, Stefan raised first the hand, and then Simon. Yeah.
Yes, thanks. I was just going to briefly add to your follow up to what you said. I think game theory can be used to describe human behavior, but one of the biggest criticisms in the past has been that people are actually not precisely following this utility maximizing paradigm. And this is why we have this whole big field of bounded rationality. But yes, I think pondering about the interests of an attacker and why he's actually trying to get into the system is can provide good insights on where to fix the issues that we have. And we're entering a multidisciplinary project next year where we're working together with psychologists to do really the empirical studies on what motivates people to care for security, or why they don't care, or why they just refrain from implementing security when they configure a system. So what keeps them from staying away, how they feel about it, and what can we do to make that more attractive and more usable. So yes, I think the road ahead is promising, but it's not without obstacles.
Sure, of course, yeah. So concerning like not fulfilling the theories, that's perfectly right. And I also visited the online lecture from, I don't know which university this was, on Coursera. And it was interesting. So they like post their theories, like which has been there for years more or less. And then at each session, they collect data from the students. And typically they have two peaks. The one peak is like following the theory, and the other one is like following if you have no idea of the system, yeah. So if you have no idea of the game theory, you would react in a different way. And this you could take this as a contradiction to the theory. So you say this is not right, or you can add that to the theory. And I think this is part of it, so that you make your new theory based on the findings which contradict your initial theory. And then again, you are like at the point where this works. And I guess this is also kind of a personal perception of the topic, and maybe shows also that game theory as is quite nice for some areas, but can develop applying it to other areas, because you learn that you need to like include new facets and new points, and for us as researchers opens no possibilities for publication, right?
Thomas, there's another hand raised by Stefan Huber.
Okay, I don't see that, but of course he
virtual hands in the Teilnehmer section.
Okay, no, I don't see it. I don't see a raised hand, but of course, Stefan, please.
Thank you. So regarding the game theory aspect, so if we want to apply game theory, we need to assume intent, right? Now, at least 10 years ago, the situation was the following, that the majority of incidents were actually unintentional, right? So my question now would be, do you have any data or experience or whatsoever, any evidence that this changed? So what's the ratio of malicious versus unintentional cybersecurity incidents?
Well, I don't think there is any, let's say, robust or reliable statistics out there. We do have a few documented cases of APTs, but it's in the nature of the thing that people were not too much willing to open up on, I have been hacked. So, or have been fallen victim to any kind of attack there. What we can say, and what is based on observations from the field, is that the initial phases of an attack, like initial contact, infection, as I was terming it, those are more or less try and error things. So the spammer actually sets out to conquer a couple of machines, or as many machines that it can, and the return or the success rate is a probabilistic thing. So those are the unintentional attacks. But once you fall victim to such an attack, which in the first case is not targeted, you typically end up getting a dropper on your machine, and from that point onwards, it is very targeted and it is intentional, because the system works like the first hit, that the first thing that hits you is really your collateral damage. But once you have been hit, any attack following that is of course intentional. And I'm not even sure if we can say that this has changed over the last years, because even if we have ransomware in the news having popped up recently, the first ransomware has been reported in the 1980s. So this is hardly a new concept. The question is more or less, did it receive the media attention back then, or did it receive the media attention today? So also, I don't think the landscape of the risk itself has much changed. What has changed is the threat landscape. Of course, we're now more diverse, there are more technical possibilities, but I think the ratio of intended versus unintended attacks, I don't think we can reliably pull out any statistics here. My feeling is it has not changed as dramatically, because we have seen those intentional attacks already decades ago.
And maybe to add to that, I also interpret the question as being, say, security incidents versus non-maliciously induced incidents at all. And I don't have any statistics either on it. My gut feeling would tell me that still, say, non-security related incidents are more common and cost more money overall, but security, say, directed and indirect security incidents are increasing with time now. So, yeah.
Okay, thank you.
Thank you very much. Thanks.
Yeah. So formally, we are at the end of the session. Are there any hot topics from the audience which should be discussed? Of course, you can discuss offline if you like. I hope all the information will be shared. And I would like again the audience, of course, for listening, for staying in the line, for posting some questions, and especially our panelists, Shadi, Stefan, Simon, and Matthias, who shared their insights in the topic and brought a fruitful discussion to life. And yeah, thanks a lot. I think this was not the last time we've been discussing together in a group, and hope we can exchange again on interesting topics and maybe share some of our insights. Vittorio, is there anything in general at the end of the session? Is there any information or sharing the appreciation of attendance or something like that to the panelists?
Oh, I think everything was okay. If we want to continue the discussion, there are some interaction rooms on the Microsoft Teams. Then we can continue also there if we want. But I think everything was okay, perfect. Okay, great. Then thanks a lot to you. So no technical problems. Probably that's due to your presence. Thanks again, and I would say have a good lunchtime, and we would officially close the session and looking forward to future meetings. Thanks a lot. Have a nice day.
Thank you. Have a nice day.
Thank you.
Have a nice day.
See you soon. Bye-bye.
See you soon.